What were the planets really like 3.8 billion years ago? That's why you might have never thought about it. It's safe to say that our Earth was home to very different creatures the long time ago. The land and water mass arrangement seemed much different, and it was much warmer. So what about Mars, Venus, or indeed Jupiter? Have they changed themselves too over the years? So before we look into each individual planet, we want to take a look into how the universe and the solar system we are dwelling today developed 13 billion years ago. A few billion years later, about 4.6 billion years ago, the stellar explosion that gave rise to our Sun and solar system had a fallback, generating a cloud of debris from which a group of protostars arose. Our Sun was one of these stars. The giant planets had already been forming shortly after the birth of our Sun. First, they had 4 bodies orbiting the proto-Sun: Jupiter, Saturn, Uranus, and Neptune. It was about 4.59 billion years ago, and you have Uranus and Neptune even. They're closer to the Sun today. The early solar system may have had other gas planets and ice giants too that were ejected from the solar system because of gravitational effects. Nearly 55 billion years ago, our Sun was starting the actual fusion processes, and the solar system had light. Debris, dust, and gas joined to form Mercury, Venus, Earth, Mars, and asteroid Vesta, apparently 50,000 years later. And in the very early days, the Earth must have suffered a collision with a planet the size of Mars to form the Moon. The Sun, however, then split off from the protostar siblings between 4.5 and 4.1 million years ago. These stars have been separately existing as separate star systems and wandering their way through the Milky Way galaxy all on their own since then. There probably was a bit of a tussle or two going on in the solar system in the following 2 million years or so, and the giant planets moved outwards while the small rocky worlds decided to circle the Sun directly. Thousands of asteroids and comets had flown through the solar system between 4 to 3 billion years ago. It was small world bombardment that changed this class of worlds, and whose losses caused all of the inner planets to break apart through widespread volcanism. Comets could bring water, or some of the first building blocks for life, to Earth. The growth of biological organisms actually began on Earth 3.8 to 3.5 billion years ago, but photosynthesis only 1 billion years later set oxygen on its path to allowing life as we know it. Let us now see what the individual planets looked like 3.8 billion years ago. Earth, without oxygen. The Earth was a radically changing and geologically tumultuous place in the Archean about 3.8 billion years ago. During this epoch, the Earth was volcanic blown and the first continents and oceans occurred. During this time, the Earth had met numerous large cosmic bodies. Today's topography and the chemical composition of the planet took on their present form in these collisions. From analysis of the composition of the Earth's atmosphere, it probably was rich in water vapor, carbon dioxide, nitrogen, methane, and other gases. The first life forms began to be seen during the Archean in the oceans. It is thought that the first simple bacteria were based on methane, not oxygen the way it is today, and Earth's first landmasses appeared above the water 3.8 billion years ago. First processes like plate tectonics became, and more complex geological development, and later more complex life forms were set into place. Water on Mars likely looked very different 3.8 billion years ago during the Noachian age. At that time, the scientists suspect Mars had a denser atmosphere, more water on its surface. It's assumed there were rivers, lakes, or even oceans on young Mars. Though these features are now recognized geologically, the biblical understanding that liquid water once flowed on Mars drove such hydrological processes is supported by the earthly evidence. Dried-up river valleys, former lakes, and sediment deposits are all witnessed signs. Likewise, the so-called Martian channels are likely to have been formed by liquid water. At that time, Mars was probably wetter and had a denser atmosphere. It may even have been simple creatures such as bacteria or simple algae within this wet world. Mars conditions on the surface changed dramatically, but over time Mars lost a large part of its atmosphere. Today, except for carbon dioxide, there is almost no atmosphere. The liquid water deposits have already disappeared away, and Mars's surface looks like dust and rocky formations. We don't fully understand why Mars changed. Many probes are currently trying to work out what has happened to Mars over time. Life on Venus 3. Venus, for example, was also in the Archean about 8 billion years ago. Besides enormous tectonic activity, large quantities of liquid water probably resided on Venus. Venus is still not so easily reconstructed. It is covered in a dense atmosphere. There are so much and we know so few surface details. Like early Earth, the planet Venus was thought to have had conditions that included a global ocean. Perhaps there once was an atmosphere on Venus that was thicker than what we have today, and that atmosphere had certain things in common with what the Earth first had. On Venus, early on, the extreme climate change was caused by the very intense greenhouse effect, which was reinforced by dense atmosphere and proximity to the Sun. On the surface, temperatures rose very considerably. The water was evaporated, and rather than being lost due to a runaway greenhouse effect, Venus experienced a runaway greenhouse effect, where the water in the atmosphere was completely lost and the atmosphere filled with massive quantities of carbon dioxide. The planet Venus also became a hot, dry world, with an impenetrable cloud cover of sulfuric acid and a surface pressure that would squish you and produce hellishly hot temperatures of around 400 degrees C. Mercury is literally covered in thousands of volcanoes. Mercury, the smallest of the inner planets, has been subject to violent upheavals 3.8 billion years ago. However, impacts from asteroids and comets and collisions with neighboring planets are probably the causes of enormous volcanism. The surface that we see today had been shaped by these processes. Such a small-sized planet, combined with lack of recognizable signs of plate tectonics, indicate a fairly limited amount of geological activity. In addition, some believe Mercury used to have a faster rotation and was then slammed into its current rotation, and one Mercury day is made up of about 2 Mercury years due to its gravity and with regard of other celestial bodies or by the Sun itself. NASA's Messenger probe is zooming in at Mercury to learn more about its past. Jupiter. Thanks to peace and quiet, let's move on to the largest and most worthy planet in the solar system, Jupiter. It was about 3.8 billion years ago that Jupiter was in upheavals it didn't even know existed. Did you know that Jupiter nearly was Sun, probably formed along with the other protostars including the Sun, but had a bit of mass missing, so rather than becoming a shining sun, Jupiter was a planetary gas giant 3.8 billion years ago. The planet likely underwent accretion of matter from the protoplanetary disk around the then young Sun. That means that as it was forming mass, it was still taking in leftover mass from the formation of the star, which means what you have growing bigger and bigger. It is thought that Jupiter accumulated much gas and dust as it was forming early. For example, hydrogen and helium. Jupiter probably began pulling in material from all around it over the course of several million years. As it is so gravitationally far from Jupiter, it has no atmosphere, making Mars difficult to transport matter from the planet to the Tunist. Jupiter's atmosphere is crossed by a multitude of cloud bands and cyclones, including that spectacular giant storm, the Great Red Spot, which has raged at insane speed through the atmosphere of this planet for hundreds of years. Probably also crucial were the young Jupiter's participation in shaping the outer solar system. The planets on the outer orbits were stabilized by the mass and size of Neimo, and the inner planets were shielded from the many asteroids and comets by the planet's increased gravity. Saturn is a giant dust collector, so let's see how the still young Saturn fared in this very early part of the solar system. Saturn was also formed by the accretion of matter from a protoplanetary disk around the young Sun, and it also had a large mass, and it may have already begun to form its first rings of dust from sunburst debris when he was forming. Probably, Saturn gathered up large quantities of hydrogen and helium. These gases make up a large part of Saturn's huge atmosphere to this day. Later, a slew of further rings resulted from the complex interplaying of many moons with countless particles swarming the planet. Today the rings are made of ice, rocks and dust-sized particles of various sizes. It also therefore played a role in stabilizing and shaping the entire solar system, as did Saturn. Without doubt, its gravity played a role in any asteroids or comets that made it into stable orbits around the Sun. Uranus glowed blue. A great deal remains unknown about the history of how Uranus came to be. Uranus was one of the first planets to form from the protoplanetary disk around young Sun, and that's what's assumed. A massive atmosphere was forming, as large amounts of gas and dust were caught by Uranus during this time. This extreme tilt of the rotation axis could be explained by the result of a trial of strength between Jupiter and Saturn. Perhaps one day, Uranus was the center of Jupiter. Then it was kicked outwards. Unusually, Uranus, like Pluto, is almost sideways, so that its poles are almost in the plane of its orbit, instead of almost perpendicular to it, as is the case with most planets. Bayer, 3.5 billion years ago, was probably already glowing in its normal pale blue luster. Light is scattered in thick atmosphere of hydrogen, helium, and methane to give color. We do not know if Uranus ever had an icy surface from its early years. Today there's almost certainly water ice, ammonia, and methane ice in large parts of the planet. Did Neptune ever exist? Like its neighbor Uranus, Neptune's early history is as obscure. And so, in a manner similar way, Neptune likely collected gas, hydrogen, and helium from its neighboring protoplanetary disk. It took millions of years for the accretion process that formed a massive atmosphere around the planet. There are significant traces of methane on Neptune as on Uranus, and the science of Neptune's atmosphere is similar to that of Uranus, but the proportions are entirely different, and Neptune is a deep blue. Intense stormy activity is characteristic of Neptune, and like all ice giants, it has extensive bands of ice or rings which encircle the planet. It looks similar to Great Red Spot on Jupiter. It features a large storm called the Great Dark Spot. In fact, Neptune's surface, geological processes on Neptune, and what those processes could be, even look so strange that some scientists have even offered theories that Neptune wasn't sent into the solar system. It is possible that Neptune moved to us from somewhere else at some point, or perhaps has come from another system altogether. Was Pluto warm? Since 2006, Pluto has only just been officially deemed a dwarf planet. But let's take a look back at what was happening with this most distant planet 3.8 billion years ago. Like the other outer dwarf planets, Pluto could have been formed together with the inner rocky planets gravitationally or otherwise, and become so small that they were zipped outwards completely billions of years ago. We think that Pluto was a geologically active planet with volcanism and processes very much like plate tectonics. Even years after the New Horizons probe visited Pluto, traces of this can be seen today, and Pluto continues to surprise researchers with its unusually varied and active surface. Pluto could have been a warmer planet, with volcanoes if it was once further inland. It's been a nitrogen and methane ice world, orbiting far out in the solar system since. Click subscribe now. More exciting videos are to come.